Hello and welcome to the stream. I think I'm live. I'm going to quickly check. And I'm live. Hey guys, I hope the levels are okay. I'm just off screen right now. I'm going to just very quickly do some housekeeping on my end. And we're going to start this really quite a simple workshop actually. The example project I want to write today is going to be very simple in concept. It's going to be a very simple C# UWP game. Kind of a number puzzle game. Right now, I'm just doing a little bit of housekeeping on the back end of things. So I shall be there in a minute. Just gonna share the link on my LinkedIn. As a heads up, might be some issues with the stream. I am using a laptop that's on life support, so to speak. Therefore, if the stream cuts off because I ran out of battery because it really doesn't last long, I'll try to be up and running as soon as possible. Otherwise, you'll see me shuffling in front of me. That's me shuffling my laptop so that charger doesn't go off charge, a little volatile like that. Okay, just got my stream link. I'm just gonna quickly share it on my LinkedIn. I'm gonna get started. My computer is a little bit slow. It's an old laptop, so do bear with me. If this posts or not, it's fine. Let's double check. And I just need to quickly get the link. It doesn't really, it kind of crops out the URL unless you get the right one. So I'm going to edit my post. I do appreciate this has been a while since I've actually uploaded a stream. This should be quite fun. Um, I have the agenda there on the notepad. Yeah, just taking a minute to just do some housekeeping in the back end. Laptop's a little bit slow right now as I'm doing many things at once. I'm gonna just quickly get my link up. Just off screen right now. And this should be a fun one. I actually made a very simple proof of concept puzzle game, like a number puzzle game. The idea is that it's based off Dr. Kamashima's style of brain training. If you ever played that title on the Nintendo DS, you would know that it presents you with these arithmetic questions, and you have to solve them as fast as you can. That's the sort of concept I want to go with. You have to solve these numerical arithmetic questions in a certain amount of time, and that's the whole idea of the game. So, with that in mind, it's going to have functionality in mind as opposed to, should I say, the UI being overly pretty. And I do this because it's obviously a very condensed stream. I'm trying to aim for like an hour or two max. I've just updated my LinkedIn off screen, so we're ready to go. Should be right for now. Get rid of this, and we can get started. Make sure my OBS is okay. Just gonna quickly check off screen. I am streaming over a Wi-Fi connection, so I do appreciate if the internet is really slow. Yeah, sorry about that, guys. Um, Otherwise, let's go with this. Let's roll it. See what happens. I'm just really hoping that everything is somewhat stable in the stream. Otherwise, it'll be re-uploaded as a video or something like that. So let's get straight into this. So what do we have here? We have a Universal Windows project, or Universal Windows Platform project, better said. I'm going to go ahead and run this without debugging, just so we can see what we have. Again, I'm not presenting the most prettiest UI with this example in this workshop, but rather what I'm aiming to do is to go through the more of the business logic side of things. How do you code a simple number-based puzzle game? That's the whole premise of this workshop. So again, things might be fairly slow. We'll see how things go during the stream. Um, as for my program, it will probably take, every time I hit start, it'll probably take anything between 10 to 30 seconds to load because of just the load of the laptop. But it is what it is. We're going to roll with it. As we're waiting for that, I'm going to walk you through the agenda. Hopefully you can see okay what I've written on the notepad. So the first idea is to generate RNG equations. So these equations have to be very simple numerical based equations that rely on two coefficients. So we're going to RNG one coefficient. We're going to RNG a second coefficient. And we're also going to RNG an operation. This is going to be really kept simple. So I'm looking to RNG like plus and minus. So we're going to have an equation that relies on the left hand of the operation, the right hand of the operation, and operation itself. And we're going to store these values in memory. We're going to also pre-calculate the answer and store it in memory. This is going to be used to evaluate the user attempt to answer the question. The build is still going with the Visual Studio session. It's taken a mighty long time. So I'm going to buy some time by continuing to speak about what the agenda says. Here we go, actually. It's going to be here in a second. Very simple stuff. When it loads, you're just going to be met with like a white screen with like 2 XAML controls. It's going to keep this extremely simple. I'm not going to use Win2D for this because I might make a separate stream or video regarding like a more, should I say, a game project that is closer to a prototype in that it displays more of the proof of concept visually speaking. This is more of the functionality proof of concept, as you can tell. And I might even adjust some of the XAML controls because, again, this is just stock stuff. So there's actually a text block you can't see because it's embedding with the background. And in here, there's a text box, which as I type, you can see the numbers 1, 2, 3, 4, 5. Hopefully it's really small there, but hopefully it's not the hardest to read. 6, 7, 8, 9. I can even do text. There's probably going to be some low-level validation to kind of ensure this sort of information that I'm writing here is numbers, or we're evaluating numbers to just avoid errors. So the concept is there's going to be an equation that pops up here. We're going to answer it by filling out the text box, and then the program is going to evaluate, it's going to fill in blanks basically, so to speak. That's the idea here. Not going to pretty up the UI too much, but we'll see how things go. If there's time, I might be able to make things a little bit nicer, visually speaking. So let's kind of dive straight into this. So the first things first, what I want to do is to draw your attention to what I've already written here. What is here is basically a few lines of code. I've got a few one namespace. I've got this models namespace. And within this namespace, there are 2 functions, calculator and input parser. Now, in order to, if you're familiar with any kind of like game development, you'll probably be familiar with this concept of an update loop, or maybe a draw loop, or some kind of logical loop that loops indefinitely in the background of the game. And this serves as a kind of a backbone to evaluate all the business logic and rendering logic of the game. It will run at a certain frame rate depending on the games. Some games target 30 FPS, 60 FPS, whereby a certain level of graphical computation is displayed, or the output thereof, some kind of graphical computation is displayed on the screen at a certain frequency, being 60 frames. I'm using what's known as a dispatcher timer to kind of create this pseudo update loop. I've called it update clock. I've set its properties. The interval controls the speed. I've set it to, I believe that's 1 millisecond, which is the maximum speed you can set it via the time span struct. Or actually, that's a time span function. I thought it was a struct, but it seems to be a function. The tick property, it just basically sets up the event that is hooked to this particular tick event. The method being the update method here. So every time this clock ticks, the update method is called, okay? And then start simply launches it. So as soon as you saw my UWP app start, this was already ticking in the background. I could even set a breakpoint here and run it in debugging mode. You'll see this break in that we will step through this block of logic. But I'm not going to do that now because it's going to take a bit of time. I'm going to save this because I like to save often. And what do we have here? So basically, this core window underscore key down, what it does, let me see where I am. I set up in the constructor this event, and it calls the key down typed event handler, and I'm hooking it to this core window underscore key down function. So every time I click a button on my keyboard, this function should fire, and we're going to use this to help evaluate our logic. Right now, all it's doing is assigning this value to the return value of this function, parse key input, which actually resides within this models namespace in the input parser class. And all it does, it returns the key that was pressed. It seems a little bit redundant because you can probably um, um, just innately get the value of the key from the argument, from this parameter here, this argument, which is key event args e. But I thought it'd be nice to have a returning function just to sort of have a little bit more control over and a little bit of more organization over what's going on. It could come in handy, this logic. So where are we going to start here? We want to kind of display an equation so we know what's going on. So for that, we need the backend to be, um, reflective of what we want to display on the screen. So we're going to first generate coefficients. I have a calculator class, which I've already made a little start here. I have an RNG, a random class called RNG, and I construct it here on this line. So anytime I call this function generate coefficient, which is the first thing we want to do, we're going to create a random number, a random int, between the ranges of 0 and 20. And I think that's inclusive. I'm not 100% sure, but I think that's inclusive to some degree at least. I'm going to return its value. So I think a good place to start, as I've said on my notes, generate coefficient, call generate coefficient for the first coefficient. What I'm going to do is in the update logic, we want to say, okay, I've written here, check the game logic. So I want to say generate a coefficient or generate the coefficients and the should I say operation for the current round, because every round is going to present us, the player, with a different equation. So we don't want this to change on every loop, so it has to kind of have an initialization functionality. And we're going to use, I'm thinking on the top of my head, we can use Boolean flags to help to control this. So let me see what the best class is to have this Boolean flag. Could just pop it in here. But I think it might be more appropriate to put it in the calculator class. And we could even have another member of models in the form of a class that holds all the values. But for now, for the sake of time, I'm going to actually just pop it in here. Let me just quickly check my stream off screen, make sure everything's fine. I'm aware that I'm getting a warning that my bitrate is quite low. I'm hoping the stream is stable enough. But anyway, let's carry on with things. So generate coefficient, where was I? Okay, so we'll generate the first coefficient. So I'm going to go ahead and grab this. Oh yeah, but we need our values. So let's go ahead and make it, and again, this is not the best rule of thumb. I'm going to just disclaim now. You should have public properties, or rather you should have public properties that expose public properties, sorry, that expose private fields rather than private fields in themselves. But because of the sake of time, I'm going to make public fields straight away. So I'm going to say, and this should actually be private, it doesn't need to be public. I like to always define my accessibility keyword for my members. So let's just say public int, public int, and I'll say, for example, let's just say coef, as in coefficient. Coefficient 1, just declare that. Public int coef2, declare that. And for the operation, there's no actual data type that I know of. Maybe there's one in the math class. I think there's a math class. But I'm going to just use booleans for plus and minus. I'll say I'll just say op. I'll declare that now. So it can either be plus or minus, so one or the other. That's what I use to keep things really simple. All right, so now what we're going to do, we're going to call this generate coefficient. So I'm going to go back here. And oh yeah, there's one thing I forgot. So under the calculator class, I'm going to also have public boolean init for initialize, I'll say equation equals false. So every time this is true, we don't want to generate the coefficients because we already have the coefficients. And because we're going to generate the coefficients in the underlying update call, the underlying update call is going to fire on every frame, so to speak. That's why we need to have initialization logic to control that flow such that we're not always generating coefficients. Hopefully that makes a little bit of sense, as I'm sure you guys may agree with. So what am I going to do here? I'm going to go back to my main window class. Again, I'm trying to keep this as lean as possible. I mean, this class doesn't really need to be more than a couple hundred lines of code at best for a game as simple as this, I think. You really don't want to have a bloated class, main window class, with too much underlying business logic here. But sometimes, because the XAML is so tied to this class, of course, it can't be helped sometimes. So what I'm going to do, input parser, I think I have a declaration here. So input parser. First, I'm going to have my validation check in the form of an if statement. If the input parser class, and I'm going to access, oh, sorry, no, that's the wrong one. I meant calculator. I don't think I've even, I need to construct the calculator class. So what I'm going to do, don't really need to copy and paste it, I'm just going to do it anyway. No, it's better to write it out so you guys can see. Models, calculator, I'm going to call it calculator. I'm going to instantiate this, new models.calculator. So now I have my class. Quickly write a comment there. So now this gives us access to the calculator class. We have an instance of calculator. The majority of our business logic residing here, calculator. So I'm going to say this calculator now should have access to my coefficients. Let's see what we need here. If init equation is initialize equation should be set to false, I think, because that's the initial value I set it to. Even though the name convention makes that a little bit confusing, not gonna lie. Anyway, so if this is false, then I'm gonna go ahead and generate the equation. So now I can call calculator. I can call generate coefficient, and I can store the value. So I can say this calculator dot coefficient 1 is equal to this is a signed value of the randomly generated integer between the range of 0 to 20. Trying to make it not too difficult because not all of us, are prodigy mathematicians. Myself, I'm the first one to put my hand up for that. I'm definitely, not really the most mathematical person, but I do appreciate maths. It's quite an interesting topic. Anyway, so then this coefficient 2, again, we're going to call the generate coefficient, and we're going to do that. Similarly, we're going to get the operation. We're going to give it its value, which is a Boolean data type. So I'm going to say generate operator, which returns a randomly generated bool, I believe. Let's just double check. So I'm constructing a new instance of random, and there's a range of 0 to 1. If 0 return false, that will actually mean that will signify minus. Else, if 1 return true, which will signify plus. Very simple. This is a simple logic. So where are we? Let's just have check marks so we know what's going on. So we generated our coefficients so far, it seems. Haven't really run the program yet to know, because I'll probably run the program at this stage when we're displaying on the screen so we can see what's going on. So for now, just to save time, because I know it takes time to boot the program, store the values in memory. We've done that just now. Store the answer in memory, we're going to do right now. So after we have initialized the equation, we want to actually set this init equation boolean to true, so that this actually validates this for false, this logic, and such that it becomes a sort of initialization logic. It won't pertain to every update call until this flag is set to false. So this protects this logic. This is actually protected. That's great. So now, what are we doing? We've generated our equation, so to speak. We have the coefficients and operations. So what we need to do now is calculate the answer. Do I have a variable to store the answer? No. So let me do that now. Put it here. I'll say public int answer. Declare that. And I'll just grab this line, copy paste. Answer. Calculator. We're going to go for coef1. We're going to call the int keyword. We're going to call parse. And we're going to basically effectively cast this string as a number. So we're going to say the answer is equal to, we're taking the first coefficient. We're adding it to the second coefficient. Let's see if we're doing this right. Int parse answer, which is an int. Can convert int to string. Parse string. Coef1, which is an int. I probably overthought that just now, didn't I? Let me just see here. So I don't need to cast anything because it's already in. I thought it was a string because I was thinking ahead of myself. I was thinking about the fact that the text box for the visual is a string. We're not casting just yet. So we could just go ahead and say calculator coef1 plus. Well, actually, to calculate the answer, it depends on the operation we're using as well. So we're going to need a little bit of validation. So if we're adding the coefficients, we're going to use an if statement for validation. So I'm going to just protect this code with some validation in a minute. So if this operation is true, in other words, if we're adding our coefficients, we do the following. Else, if the operation variable turns out to be a false value, which is RNG decided, then we actually want to change the operation to our minus operation. So we're minusing the coefficients, and then we're storing the answer. And then we trip init equation to true, thus protecting this, kind of closing off this logic from the loop. That's the first part of the update loop. Okay, so well, we've stored the answer in memory, if I'm not mistaken. So what I want to do before I run the program is to just visualize the equation on the screen. That's nice. Some juice, some kind of juice. I don't even know what flavor it is. I can't really tell. It's like grapefruit, anyway. Yeah, so in order to do this, we might as well have the display logic in this initialization, because the question is not going to change until the round changes. So what I'll do, let me check my OBS, make sure everything is, yeah, that's fine. Am I streaming still? Yeah, I'm online. Okay, sweet. Where am I? So visualization, we want to do this. And we don't want to show the whole answer, of course. We want to actually display like only one coefficient. And in order to do that, we're going to create this function called display equation. So before we even visualize, we're going to have to make a function called display equation, which only displays part of the equation, and it doesn't expose the answer. That has to be user guessed, basically. So this part we're going to get to. So I'll put a little checkbox here. So probably the best to have this display equation here in the calculator class. Public, I think it'd be void, I'm not too sure. Display equation. And I got some pseudocode to help guide me here that I wrote earlier. Yeah, so what did I write here? If operations equal to true. So I'm doing all I'm saying here for now, and this is kind of so I'll run through what I'm saying first and I'll kind of evaluate the solution. So if the operation is an addition, I'm going to display as such coefficient plus blank, and then there's an answer. Else, if it's a minus, it's going to be the um, coefficient minus blank equals blank. Obviously, this is very simplistic. It's a quite naive approach, but again, we're going for simplicity for the proof of concept. Let's have our if statement. Where am I? Just highlight so I don't get too lost. So I can say if this operation is true, this is let's actually return a string. And the string will just be the equation written out as a string. Let's see if this works. So we're going to say the string will be as follows. I could store this in memory, but for now I'm going to leave it like this. Coefficient 1, toString, plus, we're going to leave a space, and we're going to say plus, and then this is going to be blank. So it's going to be plus blank. If it will allow me to do that. This seems to be, maybe that's a delimiter of such. It's a keyword probably using that. I don't even know why that's happening. Let's do like this. And then I'll just do the whole thing on one line, in one quote, I guess. Actually, not to write equals. So we're saying coefficient, let's say it was 2, then we're calculating that with this string plus blank equals, and we're going to say blank. And the user is going to have to guess the second coefficient. Let's see, not all paths return a value. I think that's the error. And let's say else. Quite similar, but in this case, it'll be coefficient. Let me see, is it still coefficient 1? You know, this is a naive approach, but I'll still stick to coefficient 1, but I'll just change the sign. So coefficient 1, toString, concatenated with minus. So this tells the user it's a minus equation equals to blank. So there we go. Display equation is there. And get ready to call the function. Update UI. We still haven't tested to see if that works. I'm not going to check it just yet. So where are we going to call this? We might as well call it in the update loop, in the encapsulating initialization logic, so to speak. So after we have determined our values, we're going to display the equation. So I can say something like calculator, and I'm going to call display equation, and it returns string. So then now I'll get the question text block, which is a XAML control that I set up. .text is equal to the text of the text returned by display equation. Might as well test this out. Not sure what's going to happen. I really want to change the font size because it's really small. Let's see what we could do. So text I'm going to change this to like, I don't know, 30. As for the text block, I want it to be even bigger, maybe even bold as well. Hopefully it'll all fit. Make it like 34, see what happens. Might need more space, so I'll just bring that out a little bit. Don't need so much space on the right hand side of the screen, so I'll just bring that there. But now the scroll bar disappeared, so I'll bring that out a little bit. Okay, let's test this out. I'll run it without debugging first. It's for speed, and if there's issues, I'll debug if needed. Okay, how am I doing for time? I'm gonna quickly check off screen what's going on as the UWP program is loading. We're about half an hour in. About half an hour in. Just waiting for UWP to load over there. Just waiting. Just checking my levels. It seems a bit soft, but it might be coming out okay. I did a bit of a sound check beforehand, so hopefully everything's okay. Yeah, this just takes a little minute. And let's just assume, if we assume everything is working so far, as up to what we've done so far, I'm gonna tick that off. I'm gonna tick this off, and then we're gonna start dealing with actually solving the arithmetic and doing a little check, and then displaying that. And if there's time, I'll sort out a round system, which isn't really difficult. It's just really storing the answer or storing a score or something, and then refreshing all the members, all the variables, and then just literally calling the initialization logic again, all this good stuff here. And even a countdown clock would be quite fun. Ah, we have something here. Excellent. So we have an equation on the screen, if you can see there. It's a little bit hard to see. I'll try and blow up a little bit. I might have to change it to the center to just make it look quite nice. I've got 14 minus blank. Now here's the thing, I completely forgot. So obviously we need to see the answer, because how are we going to solve an equation where we have only one coefficient and we don't know the answer? That's my fault. That's on me. So we're going to solve that. But so far we've displayed the equation, or an equation. I'm not going to tick that off just yet, so I'm going to go back to the calculation. Firstly, I'm going to actually go here. I'm going to go to the text block that displays the question. I'm just going to see if I can center the text. It's already set to center, which is very interesting. Fascinating stuff. Oh, no, it's set to left. That was very interesting. I'm going to go back here. I'm going to increase the font to like 42. And yeah, is this enabled? It shouldn't be disabled. This should definitely be enabled. Let me check the properties. Because it's gray. Yeah, just I colored it gray. Okay, that's fine. All right, save that. I'm gonna go back to my calculator class and consider the way that I'm displaying the equation. Display equation, coefficient. Instead of a blank for the answer, it's gonna actually display the answer. So I'm gonna say answer toString. I'm going to go ahead and close my parentheses here, leave a space. I'm going to put the concatenation symbol as such. I'm going to just grab this. So coefficient 1, concatenate plus concatenate answer. Coefficient 1, concatenated minus, let me see if I got that right. Minus blank. I did that wrong actually. Minus blank equals an answer. Oh, I'm clicking buttons. equals off for some reason. Anyway, that should be fine. Test this out. Hopefully we have one coefficient and one answer, which would hint to what the second hidden coefficient is that we need to, as we like me as a player has to guess. So yes, waiting for UWP to load. I kind of see what I can do ahead of time in terms of what to do after this. So let's have a look at the agenda. So it's just about solving, evaluating the equation that has been attempted. Okay, so this is fairly simple stuff. If I get this wrong. So yeah, and obviously 3 minus 3 is 0. So if I enter 3, the way I want to do this, so make this a little bit smaller. Now that we have a decent formatting for the screen, I'll make this a bit smaller. So the thing is, I should make this box a bit smaller as well. I don't know. I could do that later. I really should do that. Anyway, the way I want to do this, I wanted to say, okay, if the key presses enter, so if you enter 3, you're locking in your coefficient. You're saying this is what I'm guessing it to be. I actually initially wanted it to be so that you have to guess the operation as well to make it a little bit more fun. But that could be a second part. I'm just taking this as simple as possible. So we're just guessing the number effectively. Just one item, one element of the equation, which is the coefficient. So yeah, that should give us the answer. Where am I? So let's continue with this. I'm gonna strike this off as complete. We've done that. This one effectively is the same target. And now what am I gonna say? If enter is clicked, I'm locking in the number that has entered as a coefficient. So what I can do, if I go back to my main window, or my main page rather, within my update loop, over here, update, I can consider saying in this section, I can have an if statement to evaluate some a piece of logic. Yeah, I have it here actually. I don't need to think too hard. If the currently pressed key which is stored every time we press a button, is equal to virtual key dot enter. Oh, I used the wrong operation. Then I'm going to say evaluate the answer provided, if the answer is right or wrong. Whoops, I just nudged the camera. Sorry about that, guys. So, where am I? And I can put some validation as well, which is what I did here. So I only want to evaluate numbers. So, and the coefficient provided is going to be, in this scenario, it's just going to be the text answer. So I'm going to say the answer, the control, the answer text box, text, I'm going to cast it into an int. Greater than equal to 0. I need the or symbol. Let me just quickly, funnily enough, I can't access the or symbol on my keyboard, so I have to Google it. At least I'm not aware of a way to access the or symbol, so I'm going to Google it now, copy it to my clipboard. Goodness. Just off screen quickly. Sorry about this, guys. So I'll just quickly get the or symbol. Okay, sweet. Logical or. So if the answer is greater than or equal to 0 or less than equal to 0. Gonna just parse it. Int parse. My charger's just gone off. Let me just quickly, before the laptop dies on me midstream. I don't want that. So this validation, this if statement validates that I'm entering a number. If I enter a piece of text, this will actually throw an exception, I think, because it can't. It won't be able to parse like a letter entered, only like number strings. So in that case, I'm gonna have to try catch around this. Catch the exception. And all I want to do is just return. I don't want to do anything. Is my bracketing off? No, it's fine. So if I've entered a number, so if I press enter and the answer I provided is a number between like 0 and infinity and 0 minus infinity, I guess, then I want to evaluate the answer. Validation of numbers enter. Let's cross that off so we can keep track of things. We're not evaluating the coefficient right now. This is something I can leave for another tutorial if I want to extend the functionality of this game. But for now, no. So what we're going to do, step 3, we're going to call answer check. So I already provided myself with some skeleton code, I think. I might be, if not, I'll do it now. So I have this function called answer check. Take some overloads, coefficient A, coefficient B, the correct answer and the operation provided. And it just evaluates the logic. If the answer is the same as the coefficients, the addition of the coefficients, then true. If the answer is the result of the subtraction of the coefficients, then I get a correct answer depending on the situation. All right. So I can simply say this calculator answer check, and I just fill out the overloads. So coefficient. In this case, coefficient A is always provided, I believe, if I'm not mistaken. Let me make sure I got this right. And make sure I fill out these overloads correctly. So coefficient A is provided already. I don't think I'm RNGing the coefficient order, so I'm going to say calculator coefficient 1. As for coefficient 2, or coefficient B in this case, it's going to be the user guessed or user attempted coefficient, because we have to evaluate that against the answer. So I'm going to say, for now, it's just going to be the parse value of the answer text box. Hopefully I got this right. Now the next overload is going to be the actual answer, which I think I'm storing in calculator. I'm not too sure. Answer and the operation. So I'm calling answer check here. Let me just check something. So I have generated the operation and the coefficient. That's fine. And that should be good to go. Am I calling the RNG for the subtraction and plus? I must be, because the equation was a plus. So something happened. Let me see where it is. Generate operation, I think it is, or something. Can't remember. Yeah, there's a reference. That's fine. So, what's going on here? On every loop cycle, I'm basically saying, okay, every time I press enter, I want to check for the answer if it's correct or not. The user is basically validating that they want to lock in their answer. That's what this is about. And this returns a bool. And the bool is like, true or false pertaining to the answer being correct or incorrect. And what we want to do is basically say if the answer is correct, then we want to proceed the round. So I'm going to actually encapsulate the answer check in the if statement. Excuse me. And took my drink. So if the answer is correct, we want to progress the round. So progress the round to conclude this session if answer is correct. And let's just say, I don't know. For now, all it's going to do is set a new set of equations, and I guess I can store a score. I'll leave that here in the main window because it just makes things life a bit easier. So I'll say like private int score. Let's assign it to 0 for now, just to make things a bit simple. Then let's just say the high score of the player. Okay. Gonna have to display that somewhere on the screen. Let's go back to the XAML. Hopefully it's not too slow. So I don't like going to the XAML panel, the XAML window. It's slow. I was trying to avoid this, but it's okay. I need to upgrade my machine, which I shall do in due course. Just hope everything doesn't crash. That'll be even longer. I'll just wait patiently. Sometimes if I click the screen once, it kind of speeds things up a little bit, so I'll do that. Hopefully that actually happens. And while we're waiting for that, just gonna look here on the right hand side. So where did we get up to? Hopefully I saved my progress, I'm not too sure. Display equation. So yeah, we've already displayed the equation actually, so I'm gonna tick that off properly. I really don't know what's going on here. Let's just hope everything's alright. Updates. Key press. I'm actually validating for the key press. I've done that. While I'm storing. Okay, that's fine. And yeah, we just need to really just check this to know what's going on here. I might have to reset Visual Studio, which is not an issue. It's just a little bit of a waste of time, not gonna lie. Let's just click cancel. If it's quicker to just reset Visual Studio, then that's even better. Guys, this is a disclaimer. If the stream goes offline, I shall be back. Because it looks like everything's frozen. It's just really annoying. I'm gonna check my session off screen if my computer is not completely frozen. Oh my days. Sorry guys, I do apologize for this. Ooh, my battery's running low. This is a nightmare. Let me quickly just adjust my battery. Stream might go offline, but that's fine. Do this. There we go. Seems fine for now. It seems to be charging. It's saying it's charging, but the charge symbol, yeah, that's the UI, yeah. This is frozen completely. Sorry guys, I'm gonna restart the stream properly, okay? So hang tight if you're watching, I'll make a part 2 upload, okay? Let's see if I can go to the task manager real quick. Might be able to salvage this. Right, I'm just gonna close this. Ooh, something's going on. Bit of activity here. I'll give this 10 seconds. Okay, it looks like it's working now. So sorry about the delay, guys. Well, yeah. So if you can still hear me, my computer just shut off because of the battery. I'm gonna try and restart things. I have zero idea what's going on. The stream is probably offline. This doesn't make sense to me. My guess is that I'm still online, still streaming. Um,